Hey, so I believe this is the 9th video in the series that I'm making on Calc 1, and finally we're up to the interesting part, I think, sorry, it turned off. Finally we're up to, I think, the first interesting part of calculus, which is derivatives or formulas for derivatives, and you should know them, like, very well. Basically, in the book, in the description, on page 144, they have the derivatives for main functions and rules. They have the product rule. That you should know. I assume we know that, and I'm just going to go through as many derivatives as I can, just going through one example after the other using those rules, but you should know those rules very well. And I'm going to be changing the notation that I'm using for the derivatives all the time so that we learn all of the notations. So let's just go through as many problems as we can. Well, if f of x, let's look at the first problem. F of x is 106.5. So if we just take the derivative of a constant, this is just 0. That's the first problem. Know what the derivative of a constant is. Derivative of a constant is 0. Second problem, same thing. F of x is equal to the square root of 30. F prime of x is equal to 0. Okay, third problem, f of t is equal to 2 minus 2 over 3 times t. I'm going to change the notation a little, so again we get all the notations. So df over dt, again, notation for the derivative, it's Leibniz's notation, it's negative 2 over 3. Okay, fourth problem, we have f of x is equal to 3 over 4 x to the 8th power. F prime of x is equal, sorry, this is a 4. Yeah, this is a 4. F prime of x is equal to 8 times 3 over 4 times x to 7. Again, just learn the rules. And this is equal to 2, 3, 6 x to the 7. Okay, next problem is problem 5. F of x equals x to the third minus 4x plus 6 df over dx is equal to 3x squared minus 4, right? The 6 vanishes, the x minus 4 becomes a 4 or minus 4. Again, slightly different notation, df. Okay, next problem is problem 6, and I guess we should do problem 6 in two different ways, one using the product rule and the other using the just factoring everything. Again, learn all the notations. It's so important, especially if you're going to go on to higher level mathematics, multivariable calculus and all that. You need to know the notations. Leibniz's notation is very important for integration, and especially very, very important if you're going to take differential equations. So learn both notations. Okay, h prime of x, and even when you do rate of changes, a lot of this can make things much simpler to know what you're doing. Okay, so we take x minus 2, product rule, times the derivative of this, which is just times 2, plus 2x plus 3 times the derivative over here, which is just 1. So this just becomes 2x minus 4 plus 2x plus 3. In other words, 4x minus 1. Second way we can do this problem, again, is by writing h of x is equal to x minus 2 times 2x plus 3. Let's just make this equal to y. And then so this is going to equal, so y is going to equal 2x squared plus 3x minus 4x minus 6 or in other words, y is equal to 2x squared minus x minus 6. So dy over dx, or in other words, y prime is equal to 4x minus 1, and we get the same solution. Next problem is problem 7, right? F of t is equal to a fourth times t to the fourth plus 8. So now again, constants don't matter. T to the fourth is just going to become 4 times t to the third, right? Again, learn the rule. So we get f prime of t is equal to a fourth for t to the third, and then plus the 8, but the 8 just vanishes, and this is going to give me t to the third. Okay, next problem, problem 8. F of t is equal, let's say, to y is equal to a half t to the sixth minus 3 t to the fourth power plus t. So f prime of t is equal to y prime is equal to the change in y over the change in t over here, which is equal to 6 over 2 t5 minus 3 times 4t to the third power plus t plus 1, right? T just becomes 1. And this is going to give me, so dy over dt is equal to 3t to the fifth power minus 12t to the third power plus 1. Okay, so next problem is problem 9. V of t is equal to 4 over 3 pi r to the third. V prime of t, constants don't matter, so we get 4 over 3 pi, the 3 comes down, r2, right, we get 3 minus 1, which is equal to 4, right, the 3's cancel, 4 pi r squared. Next problem is problem 10, rt, let's make this equal to y, is equal to 5t to the negative 3 over 5, right? So the change in y over the change in t, which is equal to r prime of t, is equal to negative 3 over 5 times 5, right? This comes down, and then we get negative 3 over 5 minus 1 for upstairs, right? So we get times t to the negative 3 over 5 minus 1, and this is equal to negative 3 t, and then this is equal, so 5 over 5, then we have negative 3 minus 5, negative 8 over 5, so this is equal to 3t to the negative 8 over 5, right? So dy over dt is equal to this. That is the 10th problem. Okay, 11th problem, not too difficult. We have y of t is equal to 6t minus 9, so y prime of t is equal to negative 9 times 6 t to the negative 10. Okay, so that was problem 11. Problem 12, interesting problem. We do know the quotient rule, so I'm going to do problem 12 in two different ways. One using the, we'll see. One using the quotient rule, and the second just manipulating it a little to the 7. So r prime of x. So using the quotient rule, right, we take x7 times the derivative of the square root of 10, which is 0, minus just the square root of 10 times the derivative of x to the 7th, which is x, 7x to the 6th power, and then we take this and just add a squared over here. So this is 7x to the 7th squared. In other words, we get negative 10 square root of 10 times 7 times x to the 6th over x to the 14th. Or in other words, we get negative 7 times the square root of 10 over 14 minus 6, which is x to the 8th. So that's the first, and yeah, so this is r prime of x. That's the first way we're going to do the problem. The second way we're going to do the problem is actually makes it a little simpler. 10 over x to the 7th. Well, this is equal to the square root of 10 times x to the negative 7, right? Because that 1 over x is equal to x to the negative 1. Very important rule to remember. So now if we take dr over dx, this is going to give us negative 7 square root of 10 times x, x to the negative 8, right? This is just using the, I don't know, I forgot what this rule is called, but whatever, right? Because we have d over dx of x to the n is equal to nx n minus 1. So we just take the n minus 1 over here. And this is equal to negative 7 square root of 10 over x to the 8th. And we get the same exact answer. That's problem 12. Problem 13, f of x is equal to a half x, is equal to 1/2 x to the 5th power. So we need to be a little careful here. F prime of x. So this is the same as 1 over 2 to the 5th power times x to the 5th power. We can't just take the derivative without first taking out the constant over here. So f prime is going to be 1 over 2 to the 5th power times 5x, 5 minus 1, which is 4. And 2 to the 5th power, so 2 to the 3rd is 8, so to the 4th is 16, so to the 5th is 32, so this is equal to 5 over 32 times x fourth. Yeah. So just be careful to take this 5 and put it here and here, right? You don't want to take the derivative when the 5 is going on the whole thing, because you can't really take out the constant from the derivative if the 5 is going on the whole thing. Okay, next problem is problem 14. F of t is equal, let's say, to y, which is equal to the square root of t minus 1 over the square root of t. Interesting problem. So we have dy over dt, infinitely small change in y over the infinitely small change in t, is going, so this is equal to a half minus, and we're going to do this again in two ways, using the quotient rule and then using what this is. So 1 over t a half. So now this gives us, so the half comes down, and we get over here a half minus 1, right? 1/2 minus 2 over 2, which is 3, which is negative a half. Negative a half. Yeah, so this is a half t to the negative a half minus, and over here we're going to use the quotient rule. So we're going to have the square root of t times the derivative of 1, which is 0, minus, so this will become plus, and this will just become plus over here, or really we'll just have a plus there. And then 1 times the derivative of the square root of t, which we already know is t to the negative a half, all divided by this t squared, which is just going to give us t. So this is going to give us 1/2 t to the negative a half is equal to 1 over t, 2t, the square root of t, right? Because that t to the a half is equal to the square root of t, and t to the negative a half is equal to 1 over t to the a half, which is equal to 1 over the square root of t. All important relationships to remember. And now, so that's that. Then plus, and now we're going to get 1 over 2 to the square root of t over t, or in other words, this is going to give us 1 over the square root of 2 square root of t plus 1 over 2 t squared of t. So that's what we get. This is equal to f prime of t. Okay, the second way we're going to use this, much simpler way. It's important to, I guess, learn the quotient rule, but a lot of times it's much simpler to just play around with the algebraic expression. So this is equal to the square root of t minus, okay, let's rewrite this from the beginning. This is equal to t a half minus t to the negative a half. So if we take f prime of t, we're going to get a half t to the negative a half minus, then minus a half, so this becomes a plus, t to negative 3 over 2, which is equal to 1 over 2t square root of t plus 1 over 2 t to the 3 over 2, which is equal to 1 over 2 square root of t plus 1 over 2, and this is the same as t square root of t, right? Because a t square root of t is equal to t to the a half, and if you add them, you get t to the 3 over 2. So that is that, right? Because when you multiply these, you add them. You add the exponents. So that is problem 14. Problem 15. Okay, so now I'm just going to do problem 15 in one way. AS is equal to negative 12 over s to the fifth, which is equal to negative 12 s to the negative, s, it's not working, s to the negative 5. So a prime of s is going to equal to negative 12 times negative 5 times s to the negative 6. Or in other words, it's equal to whatever 12 times 5 is, over s to the 6th power. And again, you can do this using the quotient rule. I'm not going to do that again. Okay, problem 16, it's very similar. b of y is equal to cy negative 6. So b prime of y is equal to negative 6 times c times y to the negative 7 is equal to negative 6 times c over y to the 7th power. Next problem. So now we have problem 17. Which is y is equal to 4 pi squared, so y prime is equal to 0 because that's a constant. Problem 18, which gives us g of u is equal to the square root of 2u plus the square root of 3u. So now d of g over du is equal to the square root of 2, right? The u vanishes, plus, that's going plus, so this is going to give us a half times 3u to the negative a half. And wait. Okay, I don't think this chapter did anything with the chain rule yet, so I can't really do it this way, because when you take this derivative, you would have a 3 come up here by something called the chain rule, which we didn't see yet. So instead I'm going to say that this is equal to the square root of 2u plus the square root of 3 square root of u. This will make things simpler. So now dg over du is that plus the square root of 3 times 1/2, right, because now 3 is a constant, 1/2 u to the negative 1/2, which is then equal to the square root of 2 plus the square root of 3 over 2 the square root of u, which is equal to the square root of 2 plus this 1/2 square root of 3 over u, which is correct. So, but just to make some point, I just want to say that let's say you had h of u is equal to the square root of 3u. You can't just say h prime of u is equal to 1/2 3u to the negative 1/2. It's not even correct, because that this function inside is not u, right? If you have u square root of u, then this is equal to 1/2 of u, and so you can take the derivative of this, because we have the rules in terms of x to the n, and n doesn't even have to be an integer, it can be any number, and over here, or the rules in terms of u to the n, and over here n is just 1/2. But if you have a 3 over here, then, right, if you have a 3 over here, you're going to have the square root of 3u is equal to 3u to the 1/2. And you can't just take the derivative of this, because this is not un. This is 3un, where n is equal to 1/2. You can't just use the same rule. We're going to learn about a rule called the chain rule of how to deal with this in one of the later sections, but you can't just do it this way. Okay, so the next problem is going to be problem 19, which gives us u is equal to it's going to be 5t plus 4 square root. So again, we cannot really take the derivative of this thing. We can't just take 1/2, because this is not t, this is t to the 5. So let's just rewrite this in order to make it simpler, and then we should be able to just take the derivative without worrying about, again, the chain rule. So this is going to equal to t to a 5th plus 4, and then you're going to have t5 to the 1/2, which is equal to t5 over 2. That's what this is equal. So it's going to be equal to 4 times t5 over 2. And then, so now everything is in terms of just t, so now we can just take the derivative. So we have u prime is just going to be equal to a 5th t 1 over 5 minus 1 plus 5 over 2 times 4 t 5 over 2 minus 1. So let's figure out what this is. So this is going to equal to a 5th t, and we have 1 over 5 minus 5 over 5, which is equal to 4, negative 4 over 5. So this is negative 4 over 5 plus 5, 4 and 2 cancel. So this is going to give me 10t, and then over here we're going to have 5 over 2 minus 2 over 2, which gives me 3 over 2, so plus 3 over, and this is a negative, no, this is a positive, 3 over 2. So that gives us what we need. So this is problem 19. Okay, problem 20, again, because we use the chain rule, we'll have to be a little creative over here. Square root of x plus 1 over, and this should basically prepare you, I guess, for the chain rule to see what you cannot do. I cannot just, when I say v prime, I can't just take this 2 down and then keep everything the same. I can't just say this is equal to 2 square root of x plus 1 over square root of that. I can't just say this is equal to that, because over here this is not x. This is not equal to x. It's some function. You cannot, the rule does not say that if, let's say, v is equal to f of x to the fifth, then v prime is equal to 5 f of x to the fourth. This is not true. This was only true if f of x equals x, but it's not true for any f of x. So you can't just bring down the 2. That doesn't work. So the way we're going to do this, because we don't know the chain rule yet, is we're just going to write out what this is. So this is going to be, okay, so square root of x plus 1 over square root of x to the third times the square root of x plus 1 over, not square, the third, whatever this is called, is equal to x plus 2 square root of x over x to the third, right? This times that is one of those, and that times that is the second one, okay, plus, and then this times that gives me 1 over square the 9 to the 9, okay. Sorry, this is not 9. Let's write it out. So this is going to be 1 over x to the third squared. So then we can put this squared down here, right? Because 1 squared is just 1, and so this is going to give me x to the 1 over 3 to 2. It's just going to be x 2 over 3. So this is going to be 1 over x to the 2 over 3. Okay, and now let's rewrite this again so we don't have to use the quotient rule, and we can do this in a simpler way. So this is going to equal to x plus 2, and then we're going to have x times x to the negative a third. So let's write out what this one is. So this is x to the a half plus x to the 2 over 3, negative 2 over 3. And this just becomes x plus 2, and then we get a half minus a third, right? Because when we multiply these, we add the exponent. So this becomes x. And okay, so this becomes 3 minus 2 over 6, which is 1 over 2. So this becomes, wrong. Yeah, so this becomes 1 over 6. So this is 1 over 6 plus x to the negative 2 over 3. Okay, so that's what we get. Let's just erase some stuff, and now that we know what we're writing this, so this becomes, okay, so this just says x plus 2 to the x to the 1 over 6 plus x to the negative 2 over 3. And now everything follows smoothly. This is going to give us 1 plus 2 times 1 over 6 x 1 over 6 minus 1 plus negative 2 over 3x negative 2 over 3 minus 1, and all this becomes 1 plus 1 over 3, and this is a sixth minus 6 over 6, which is 5 over 6. So this is x 5 over 6 plus negative 2 over 3, and then you get negative 2 over 3 minus 3 over 3, which gives us negative 5 over 3 x to the negative 5 over 3, and that is our solution. And obviously there is a negative over here. What just happened? I don't know what just happened. There's a negative over here because this is 6 minus 1, which gives you a negative, obviously. A negative 5 over 6. Okay, next problem. So that was problem 20. So let's look at problem 21, which tells us find the derivative of y equals x squared plus 1 x to the third plus 1 in two ways, by using the product rule and by performing the multiplication force. Do your answers agree? Hopefully they will. Is going to be 2, so first we just leave this the same, x squared plus 1, and then we take the derivative of this, so this is going to be 3x squared, and the 1 vanishes, plus, and then we leave this, so we get x to the third plus 1 times, and then we take the derivative of this, which is 2x. So this is going to equal to, let me see, 3x to the fourth plus 3x squared, and then plus 2x to the, what is it, fourth, plus 2x. So this is equal to 5x to the fourth plus 3x squared plus 2x. And I can already pretty much see that our answers are probably going to agree, because, okay, let's multiply everything. So when we multiply this, we get x to the fifth plus x squared plus x to the third plus 1. And now so this is y is equal to this, so now y prime is equal, and now we can just simply do this, 2x plus 3x squared, and then the 1 does not vanishes, so that's that, that is that, so we're done. Answers did agree. And now problem 22, slightly more interesting. It says f of x equals x minus 3x square root of x over the square root of x, and it asks us the following: find the derivative of the function in two ways, by using the quotient rule and by simplifying first, so that your answers are equivalent. Which method do you prefer? So I'm actually going to find this in three ways. One is the quotient rule, one is by simplifying, and one is by taking this, putting it on top, and then just using the product rule. So let's see. Maybe that's what they mean by simplifying. I don't think that's what they mean by simplifying first, but whatever. So first, quotient rule. So we take the square root of x times the derivative on top, which gives us 1 minus, and over here we're using the product rule, so it gives us 1 minus 3x, right, to the a half x to the negative a half, plus the square root of x, and then the derivative of this, which is just 3, and that closes that, minus, so now we're keeping this and taking the derivative of this, so this is going to be minus x minus 3x square root of x, and then a half x to the negative a half, and then we take all this over a half x to the negative a half. Oh, right, on the bottom we don't take the derivative, we take the square root of this, which is just x. Let's see if we can try to simplify this. So this is going to get me, this is not, okay, minus, and then we take, should I simplify this? Okay, so we're going to have 3 over 2, and then this times that is x to the 1 minus a half. So we add them, so we get a half, right? We get x to the a half, and then times this just gives me an x, so it's going to be x, that's over there, and then plus, and this is going to get me to 3x, right? And then there's a minus here, and then what we're going to have is minus, okay, and then this x multiplied with this, so this is going to get me half, it's going to give me half, and then we're going to get x, the square root of x, because of this is 1 and this is a half, so when we add them we get a half minus, okay, and over here we're going to have 3, so this is going to become plus because of that minus, and this is going to give me 3 over 2, and then I'm just going to get x squared, because oh no, I'm not going to get x squared, I'm going to get x, because of this, this negative a half and this square root of x are going to cancel, so I am going to get over here x. Right, so let's see what happens now. So in the bottom I still get an x, but let's just simplify this. So this becomes this and that become a half square root of x. So a half square root of x. So that's that. And then I have negative this minus that, a plus. Okay, so this plus and this minus cancel, and I get negative 3x, and I get all this over x. Wow. So that's what I get. So now let's let's do this by simplifying everything first. So, and maybe I'm just gonna do this in this one. Maybe I'll we'll see. So again, we have f of x is equal to x minus 3 squared of x squared of x over the square root of x, and this is going to give me, so by simplifying, what I'm going to get is x to the a half, right, because that and that are going to cancel and give me a half. They're giving me square root of x minus 3x, because of this and this are going to cancel. And so now if I take the derivative, much simpler, is I'm going to get a half x to the negative a half x to the negative a half minus 3. So what the other answer? It's going to be a half. So I believe these two are the same. Minus 3x over x. So right, this is going to give me 1 over 2 squared of x minus 3, and this is going to give me, right, a half squared of x over x minus 3x over x, which is equal to, 1 over 2 squared of x minus 3. So our answers are the same. Very nice. And should I do it the other way? Okay, let me simplify it and do it with the rule. So f of x is equal to x minus 3x squared of x over the square root of x. I'm going to simplify this a little in a different way. This is going to equal to x minus, and then this is going to give me 3x to 3 over 2, right, if I add 1 plus a half. And this is going to be times x to the negative a half, right, because I can take this x, I can put it up here and just make this into negative a half and multiply it and all this. And this is going, and now let's just look at the product rule. We can multiply this out, but let's just try this with the product rule. So f prime of x is going to be this times the derivative of that, which is x minus 3x to the 3 over 2, times the derivative of that, which is negative a half times x to the a half minus 1, which is negative 3 over 2, and then plus this, so x to the negative a half times the derivative of that, which is 1 minus, what is it, 9 over 2, x, and then that becomes negative a half. Okay, so now we have to simplify this. So what do we get? So we get, over here we get negative a half. And then we have x times that, so this is 1, so this is going to be x to the negative a half plus, so that's that times that, right? Yeah. Plus, so now we have this times that, so that gives us a plus, and then we have 3 over 2, and then this plus that, which is just going to give us a 0, so we're just going to get 1, so that's that, plus, so now we're simplifying this, so this is going to give us x at 1 over 2 minus, so this minus that is going to give us a minus 1, so it's going to give, so we're going to get 9 over 2 times x minus 1. Okay, so this is going to give us, so this plus that, so that's a negative, so this is going to give us a negative, this is going to give us a half x to the negative 1 over 2 plus 2 over 3. So this kind of looks like what we want, except for there's minus 9 over 2 over here, and then you have an x down here. Let's erase what we did, even though if we made a mistake, we're not getting the right answer, I won't be able to fix it, but I feel at that point I'll just move on and not really care. Okay. So now what we get is a half x to the half plus 3 over 2 minus 9 over 2 for x. So let's find the common denominator first between this and that. So this is going to give us 2x minus 9 2x to the half over, I feel like I'm going to give up soon, over 2x to the half times 2x. Okay. We can't do anything about this. So then, okay. Okay, so then we need to take this and multiply it by 3. So this is going to be, we're going to add a 2 here, add a 2 here, and we add a 4. So we have a 2 up here, so we have a 4 here, and a 4 here, and then we say plus 3. This is again finding the common denominator between this and the whole thing down here. This is 2x a half times 2x. Okay. It's not very helpful. Okay, I'm giving up. It's a nice try, I guess, but I don't know, whatever. Someone should, I guess, plug this into, I can do that, I guess. Pause the video, plug this into a calculator, or no, much simpler. Okay, I'll just do that. I'll plug this into a calculator, and I'll plug this solution into a calculator, and I'll see if they look the same. So I'll just pause the video. So I plugged the solutions into a calculator, and they are different for whatever reason. So I'm just going to try to do this again very quickly, because if they were the same, we can just move on. We don't have to simplify things, but you can't get different solutions. So I clearly made a mistake somewhere. I'll try to do it a little faster and more carefully. So let me just see. X minus 3x squared of x times, okay, wait, so this is going to be x minus, and then 3, so this is going to be 3x to the, 3/2 times x to the negative a half, and taking the derivative of this, so f prime of x is going to give us, so first we take this as it is, x minus 3, x 3/2 times the derivative of this, which is negative a half x to the and a half minus 1. Maybe that was the problem. So we have a half minus 2/2, which gives me negative 3 over, yeah, I think that was probably the problem, negative 3/2. So this gives me negative 3/2, right, because it's a half minus 1. Okay, and so we get that plus, and then we keep this the same, x a half times the derivative over there, which is 1, minus, we bring down the 3, so we just get a half x to the a half. Right, is this correct? I believe so. So then this is equal to negative a half x. So it's x over this. So it's 3/2 minus 2/2, which is just a half, and which is a half. So it's going to be this x to a half. Right, okay, and then minus, and these are going to cancel, so we're just going to get 3. Oh, this does look a lot, I think, like, yeah, this is starting, oh, but there's a negative here, which I did not put in. Maybe I lost that. Let me try that. Okay, the solutions are, oh no, sorry, I put the negative in the wrong place. No, still not working. Okay, let's continue and see. Wait, no, so this is plus, right, because it's negative and negative. Plus, and then you get over here, you get 1 over the square root of x minus, and then this just becomes 1 over this. Oh, okay, fine. I guess the mistake happened somewhere here. 1. So this becomes 1. So this becomes 2 over here, and then you have negative a half and negative a half. So this just becomes x. That just becomes x. So let me write this equation in. So that's 2 plus 1 over the square root of x minus 1 over 2x. No, we are still okay, right, because over here you're going to have 1 over 2 square root of x times, over here it's going to be 1 over the square root of x, and this is just going to give me 1 over 2x. That's where we get that, and that negative is there. And then over here times 1, taking that, that's where we get that. So that seems correct. Wait, there should be, okay. This should not be a half, and this should not be a half, because that we're taking the derivative of this. So there's a 3 here. Okay, the 3 comes down. That I agree with. Oh, no, it should, so it's 3 over 2 minus 2 over 2. So it should not be a negative a half. It should be like a positive a half. So now, now that we know that this is a half and this is negative a half, so they cancel. So we get a negative a half over there. So we are getting close. So the final part is when the 3 over 2 came down, the 3's didn't actually cancel. It became 9 over here. And now they're the same. So that's good, I guess. Next problem. So the next problem that I'm going to do is problem 23, which says v of x is equal to 2x to the third power plus 3 times x to the fourth power minus 2x. We're going to use the product rule for this one. So v prime of x is equal, so we're going to keep this the same and take the derivative of that. So 2x to the third plus 3 times 4x to the third minus 2, and then plus, and now keep this the same, so x to the fourth minus 2x times the derivative of this one, which is 6x squared. So that's the derivative. That is the derivative. So the next problem is problem 24. This is on page 145. So the question is y u is equal to I negative 2 plus u negative 3 times u to the fifth minus 2u squared. So what is dy over du? Well, so again, we keep this the same, so we get u negative 2 plus u negative 3 times the derivative of this, 5u to the fourth power minus 4u, plus we keep this the same, u to the fifth power minus 2u squared, times, and now we take the derivative of this, which is negative 2u negative 3 plus negative 3u negative 4. So that's the derivative. So the next problem is what they call a difficult problem, but we're going to make one simplifying step, which will make this problem as simple as the problem before. 1 over y squared minus 3 y to the fourth times y plus 5y to the third. So you can simplify this, or you can kind of use the quotient rule for all this, but we know that this is equal to y to the negative 2 minus 3y to the negative 4 times y plus 5y to the third. And now taking the derivative is, we're going to do the exact same thing that we did before. So we take this, keep it the same, right, product rule, and take the derivative of this, which is 1 plus 15y squared plus, and now we keep this the same, so it's y plus 5y to the third. Take the derivative of this, it's negative 2y negative 3 minus 3y, 3 times that's, I don't know what that is, 3 negative 4 y to the negative 5. That's that problem. Okay, next problem is problem 26, which says y equals square root of x times x minus 1. So we can say y prime leave that the same, take the derivative of this, which is 1, plus, leave this the same, take the derivative of this, which is a half, x to the negative a half. Okay, next problem, 27, g of x equals 3x minus 1 over 2x plus 1. I'm just going to do this using the quotient rule. So g prime of x is equal to the derivative of this times this. So, this times the derivative over here. So it's 2x plus 1 times the derivative of here, which is just 3, minus this times the derivative of that. So 3x minus 1, derivative of that is 2 over this squared, so 2x plus 1 squared. Okay, next problem is problem 28. I guess I will make 2 videos for this section. It's a very important section, and they just have a lot of problems here, and I just want to do a lot of them. So I'm just going to go through it. So the next problem is problem 28. F of t is equal to 2t over 4 plus t squared. So d of f over dt is equal, so this times the derivative of that, what is that again? Okay, so this is 4 plus t squared times 2 minus 2t times the derivative of here, which is just t squared over 4 plus t squared squared. Okay, that's problem. 29, I'm going to do this problem without using the quotient rule, so a slight difference from what we've been doing. 1 minus x squared. So this is the same as x to the third 1. Oh, actually, no, that would require the chain rule, which I can't do. Okay, so I'm just going to do the quotient rule again. So y prime is equal, so 1 minus x squared times the derivative of this, which is 3x squared, minus x to the third times the derivative of this, which is negative 2x, all divided by this squared, which is 1 minus x squared squared. That's problem 29. Problem 30 gives us, let's go to another page, y is equal to x plus 1 over x to the third plus x minus 2. So dy over dx is equal, so this times the derivative of that, so this is x to the third plus x minus 2 times the derivative of this, which is just 1, minus x plus 1, right, this times the derivative of this, which is 3x squared plus 1 all over 3x to the third plus x minus 2 squared. That's problem 30. Problem 31, a little bit more complicated. So we have y is equal to v to the third minus 2v square root of v all over v. So again, y prime is going to be v times the derivative of this, which is 3v squared minus 2. And now over here we need to use the product rule. Actually, we don't, because we can rewrite this. Would make things easier. Minus 2v to the 3 over 2 all over v. Actually, we can even simplify this and not even use the quotient rule. So why not do that? This is going to be equal to v squared minus 2, and then you're going to have 3 over 2 minus 2 over 2, which is 1/2. So over here you have 2, and then you have v to the 1/2. So v prime is just going to be 2v minus, and then the 2's are going to cancel, so you're going to get v to the negative 1/2. So that's a nice simple solution to problem 31. Problem 32, because we can't use the chain rule because they have not taught it yet, we're going to do it just by expanding the bottom part. So this is equal, so t minus 1 times t minus 1 is equal to t squared minus 2t plus 1. So this is going to be t over t squared minus 2t minus 1. So now we can use the quotient rule. So y dy over dt is going to be t squared minus 2t minus 1 times the derivative of this, which is 1, plus t times the derivative of this, which is 2t minus 2, all over this squared, which is t squared minus 2t minus 1 squared. So that was problem 32. And we have just reached an hour. Let's do a few more, and then we're going to stop and start a new video. So y equals t squared plus 2 over t to the 4th minus 3t squared plus 1. So y, so we can do this like that. Y prime is just going to be this times the derivative of that. So it's t to the 4th minus 3t squared plus 1 times 2t minus, and then we're going to have t squared plus 2 times the derivative of this, which is 4t to the 3rd minus 6t all over this squared, which is t to the 4th minus 3t squared plus 1 squared. Next problem is problem 34, which is g of t is equal to t minus the square root of t over t to the 1 over 3. So g prime of t, again, we can just use the quotient rule, so it's this times the derivative of that, so it's t 1 over, it is t 1 over, again I put a negative, t 1 over 3 times 1 minus a half t to the negative a half minus, and then this times the derivative of that, so that is going to be t minus the square root of t times 1/3 t, and then 1/3 minus 1 is going to give us negative 2 over 3, so this is negative 2 over 3, all divided by t 2 over 3, right, because we multiply this, but we take the square of the bottom part. Okay, so that was problem 34. Problem 35, nice generalization, ax squared plus bx plus c. Well, then dy over dx is just going to be 2ax plus b, right? C vanishes, b of x is just b, the derivative of this just becomes 2ax. Very simple. Okay, problem 36. It's nice. Y equals a plus b over x plus c over x squared, or in other words, we can write this in terms of a plus b to the x to negative 1 plus c to the x to the negative 2. So this is y. So y prime is going to be, so the a vanishes and we get negative 1 b to the x to the negative 2 plus negative 2 c to the x to the negative 3. That's the solution for that problem. Okay, problem 37. Y equals r squared over 1 plus square root of r. So y prime is, so that times the derivative of that, 1 plus the square root of r times 2r minus this times the derivative of that. So it's r squared times a half r to the negative a half all over 1 plus r, the square root of r squared. Okay. Next problem is y is equal to cx over 1 plus cx. nice generalization. So we have y prime is going to be this times the derivative of that, which is 1 plus cx times c, minus this times the derivative of that, so it's cx times the 1 vanishes, and this just becomes c. Yeah, divided by 1 plus cx squared. Okay. I'm not going to be able to do the last 4 problems in this video, so I'm going to do it in the next video. Basically, I'm going to try to finish the problems in this section. I'm going to skip eventually, like maybe do problem 64, 65, I don't know, stuff like that. Definitely, or almost definitely, problem 69, or 96, I mean. And then we're going to move on to the next section, which is derivatives of trigonometric functions. Hope this was helpful.